Hi there, welcome back. This little interlude in the restoration project for the Grundig is for the purposes of creating a warning system on the normal plug to tell us when we will have a hot chassis on that set. Now, if you've seen the series, you'll know that the Grundig Type 90U uses an autotransformer, which means that the isolation is non-existent, which means that when your mains is going in, one of these gets connected to the chassis. Now, with UK and American plugs and a few other places, you do have polarized plugs for your mains, which means that your neutral is neutral and your live is live. But in Portugal and a few other places, we don't have that, which means that if you put the plug in one way, you could have live over there. And if you flip the plug the other way around, you'll have live over there. So you can never tell when your chassis is going to be live. And obviously the dangers that come with that don't need explaining. So what I've done in the past is I've put a warning system, a little red LED that shines through the faceplate. And that's supposed to warn you when you put the plug in the wrong way around and your chassis is live, you see the red on your faceplate and you immediately take it off and you plug it in the other way around. Completely unpolarized, right? Well, I've wanted to put that warning system in one of these plugs for some time, and I'm going to do that now. What we have on this radio is this. We have our live supposed to come in here. It goes into a auto transformer, and there's our neutral, and then the neutral is actually the ground, and then your voltages are taken from here, 6.3 volts AC, and in this case it actually takes 220 volts AC. There's also another tap in here for 110 volts, which you can, if you wish, connect through a fuse to there. So what happens is your mains comes in. If it's 220, the fuse is on this line here, and it goes straight through, but it also goes to the transformer, and through auto transformer action, you can take 6.3 volts out of here for your heaters. If you have 110 volts, that fuse is in there, your fuse goes in here, and 110 goes in, 220 comes out, goes to your radio as usual, and then this obviously goes through and it becomes your B+. Situation here is you've got your neutral directly connected to the chassis of the radio. Now let's assume there's your radio, it's going in, and you touch the chassis. You are at mains earth. Okay, so when you touch the chassis, which is the ground of the radio, and it's neutral, you don't get a shock, no problem. However, if you touch the chassis and this thing happens to be the wrong way around, that's when you get zapped. Your chassis is now live and you are at earth, so you're going to get shocked. Okay, what I've done in the past is I've taken a earth wire and I've taken it to the chassis, to the radio itself, and then what I've done is from here, from the chassis, anywhere on the chassis, you take a resistor and you put a LED in series with that. The way I've done it actually is I've used a bridge rectifier. There's your plus, there's your minus, and you put a LED here. I'll draw that bigger in a second. And what happens is if your chassis happens to be neutral, it's at the same potential as Earth, so you got 0 volts, this LED doesn't turn on. If your chassis happens to be live, then what happens is it rectifies that through that resistor, it rectifies it, and switches on your LED. This would be a high brightness LED, so you get very little current leaking through to your earth, which is what will happen when this thing starts flowing. So it's not enough to trip your breaker, but it does turn on the LED, and in that case you know that something's wrong. You know that your chassis is live. So you immediately take your plug and you flip it around again. This thing over here is usually 220K. I'll explain that in a second. So this is what I've done on the radio itself. What I want to do is actually, instead of doing this here, I want to do it on the plug. I want to do it inside the plug so that I don't have to actually take a three-core wire to the radio. I can keep the original wire going to the radio, but I'll still have an indication on here inside the actual plug. And that's not too difficult. That's actually quite easy. What we do is we still have live, neutral, and earth. And what we're going to do is take the neutral. This is now inside the plug. Take your neutral. From your neutral, you take that and you put a resistor in there, 220K. Okay. And that will go to a bridge rectifier. The same one I drew back there. A normal bridge rectifier, and this will be your positive, that'll be your negative, and you put a LED in here, that way. That's all it is, okay? Now, what this means is that you then connect to this neutral the one that's the wire that's going to your chassis, okay? That means that if this thing is plugged the right way around and it is on neutral, this LED stays off. If you mistakenly put it the other way around and you happen to have live on here, that goes on, which means your chassis will be live for an instant. You take it out and flip it around. Why 220? Well, we've got, in Portugal, we've got 230 volts, approximately 230 volts AC mains. That is going through a resistor. And it's meeting here, this contraption, to your earth, which is at 0 volts, okay? The voltage drop you have across here is the LED drop, which is about 2 volts. It's coming from here, through there. On the positive half cycle, it goes through there, through there, through there, through there. So, one diode drop, one LED drop, plus one diode drop, and goes to earth. So it's 2 volts plus 0.6 plus 0.6. So we call that 3.2 volts. Okay. On the negative half cycle, that is high. So your current flows from there through that diode, back through there, back there to the top. Same story. You still have the same 3.2 volts. And this is negligible, 3.2. So we've got about the current through here, we want at approximately 1 milliamp. If this current is too high, it'll trip the circuit breaker because this is effectively earth leakage. You are creating an earth leakage on purpose to get that light to glow. But if it's 1 milliamp, I think it can go up to about 5 milliamps. But with these ultra bright LEDs, you don't need much. 1 milliamp is fine. So about 1 milliamp. And to get that, R equals V over I equals 230 over 220 over 1 milliamp is approximately 230 kilo ohms. So we make it 220K, the standard value, 220K. And it works. What sort of power do we get on there? Well, we get about power equals IV equals 1 milliamp 0.001 times 220,000 equals 0.22. So quarter watt. I use 600 milliwatts. That's more than enough. Okay. Now the trick is to fit this into here. And here's the circuit actually. It's been built. This is a little bridge rectifier. It's got plus, minus, AC and AC. and across the plus minus, which are these two, we have the lead, the right way round. Obviously it has to be the right way round, positive, negative. Okay, this resistor goes to the one leg of the AC, which is that one over there. This is AC and AC, and the other one, this one, goes to your earth. So if I can fit this in here somehow, it should work. And what I've been thinking of doing is I can fit the rectifier down there. I can get the lead through here. I can drill a hole in here. If I could draw it, I could drill a hole in here. The lead will go out there and the resistor will go to the one leg. It doesn't matter which leg I take the resistor to. It just means that the leg that I take the resistor to, obviously the other one, this side, goes to the earth, which is the center one. But the leg that I take the resistor to is the one that I then have to connect the neutral line to. In other words, the wire that's going to the chassis. And it just means that I have to remember that, and obviously when I test the chassis for hot chassis or not, I'll know that I'm right or wrong. As you can see, there's no indication of live or neutral on here, on the plug itself, because there is absolutely no difference. They're identical one way or the other. And this kind of plug is perfect for this because it allows for this kind of contraption to fit inside, and it's easier because you actually mount the one on top of the other. I tried looking at this one and it just becomes a lot more difficult. So the plug that you choose does make a difference, not in the connectivity, but in the space that you have to work with. This one is very difficult to fit in here and then get this thing connected again and screwed on. So I chose these guys. And once I've got that, I'll show you. And here it is, done and dusted and screwed together. Looks pretty neat, not much to it. Now, when we open it up, this is what we have inside. I'm going to put some hot glue on here. The lead is coming out here. Just the hole was drilled just right. The lead got pushed through. It's pretty tight in there. It doesn't have to be any tighter, and it won't move because these pins are actually holding it in place as well. And the you can't really see that, but the rectifier is down there. The one pin of the rectifier goes to the ground pin, which is over here. Of course, the two wires coming in here will not have earth. They'll go to the live and neutral. So the earth is actually just on there. The other leg of the rectifier, the other AC leg of the rectifier, goes to the resistor. It's a resistor in here. I've actually put a bit of heat shrink on there. That goes to that pin. Now we know that that pin has got to be the neutral connection to the radio. Okay, that will be the live. And we know then if we flip this around, the light is going to light up. And those pins on the rectifier have got some heat shrink. It's transparent, but it's there. I'm just going to put a bit of hot glue on here and that'll finalize it, just to ensure that this doesn't touch. It shouldn't, but I don't want to take any chances. And when you put this together, it actually looks pretty good. It looks absolutely complete. It's even got a label. Danger, flip plug if on. Now obviously you'll need to know what the hell they mean, or what the hell this means, but bar putting a whole instruction manual with it, this will have to do. Now let me show you when I plug it in. So I'm just going to take it, plug it in here. I get nothing. The light is off. Plug it the other way around. And my light is on. And of course, if that is on, flip it. And I won't get any light coming on. So that is working. Here are the two wires. I'll remove the old plug. I need to see which one of these is neutral. In other words, which one of these is actually connected directly to the chassis. And I've got the FM switch on. Everything is off there, obviously. So I'm going to connect it to this guy with an ohmmeter and just touch anywhere on the chassis. 58 ohms. That is going through the transformer, so that's the one that's supposed to be live. Let's try this one. 4 ohms. That's basically resistance through here, and I was touching the aluminium on there. So this is the one that's supposed to go to the chassis. This one has to be neutral, and therefore I need to make sure that I wire it up right inside, and it's very simple. I just need to make sure that this one, the one that's connected to the chassis, goes into here. It goes into the same connection as that resistor, and this one then goes to the other prong, which is going to be the one you want to be live. And I've actually written it on there, and now we can test it. The setup here is I've got a wire going to the mains earth tag over there. It's connected to the one side of the multimeter. The other side of the multimeter is connected to the chassis. I've connected it to the fixing frame here, which is chassis earth or chassis ground. And now I'm going to plug it in, and we'll see what happens. Remember, when you plug it in, you've got to be careful that you're not touching the chassis itself, okay? Because if you're touching the chassis when you plug it in and you put it in the wrong way, you're going to get zapped before you have time to see the danger here. So here we go. No light on there. In other words, it's the right way around. And we're measuring 1.8 volts on the chassis. Watch what happens when I get it wrong. Oops. The light is on there, and that's 236 volts. Not nice. You see the light on there? That spells danger. So if you touch any of this, you're zapped. So putting it back the right way around, I still get nervous. I still do get nervous. It's not that I don't have faith in my contraptions. It's just that I'm a natural coward and I don't want frizzy hair. So you see, that's fine. No problem. 1.1 volts. Yeah, when I get nervous, I laugh. So anyway, that is done, and it actually looks quite neat. It's a very simple solution. It's on the plug. The wire is exactly the same wire that was on there before. It's going to need a bit of cleaning, but that's about it. And I haven't had to change anything or add anything to the radio as regards the supply. So, danger, flip plug Yvonne. I hope you've enjoyed that. I hope it teaches you something, gives you an idea for when you want to do something like this. Now, I know that in some countries this makes no sense. I know that in the UK, for example, you've got your three-prong plugs and you can't put it in the wrong way around. I know that in the States, I believe, not all of them, but I believe some of them, you have the neutral tag, which is a bit wider, and therefore you can't plug it into the live. I think that's how it works. A few other places have three prongs, so this doesn't make sense. But for Europe, a lot of countries in Europe have this. And whether we're just slow or stupid, I don't know. But just to make it more dangerous, we have double the voltage that the States has. We work on 230, 240 volts. So when you get zapped by that, you will remember. And you will take the trouble of doing something like this or stay away from these radios completely. So if you've done this, if you want to do this, you're doing so at your own risk. Be very careful. You're working with dangerous voltages. But I think from now on, considering the neat solution this provides, this is how I'm going to do it for all hot chassis radios and or auto transformer radios. As we've seen with this Grundig 90U, it's got a transformer, but it's an auto transformer, so the hot chassis function still applies. I hope this has been instructive, and if you like this video, click like. It's always nice to see that people are enjoying it. And if you don't, click dislike. Like the one guy who clicks dislike on all my videos within 1 minute of me posting it. I put a 20-minute video on, and immediately once it comes on, very often it's right away, within a minute or two, there's a dislike. So I want to thank whoever that is. It just makes my videos seem more credible to YouTube. You can't have videos with just likes. They start believing that you've bought them. So thank you very much. And thank you for the ones who put the like on there. And subscribe and share and all that jazz. And if you want to support the channel directly, you can do so on Patreon. The link is at the end of the video and also in the description below. Well, thanks for watching, and bye for now. Stay safe.